Somebody hands you a shovel and says, dig, straight down, all the way through the planet, and then jump in. What actually happens to you? The answer is one of the strangest results in physics, and it comes down to the number 42. Now this is obviously impossible, so let us agree on the rules first. The hole goes straight through, pole to pole. We have pumped out all the air, and the walls somehow refuse to melt. We will come back to how wildly unrealistic every part of that is. You step off the edge, and at first, this is just falling. You accelerate downward at about 9.8 meters per second squared, exactly like stepping off a diving board. But almost immediately, something starts happening that nobody expects. As you fall, gravity gets weaker. Here's why. Standing on the surface, the entire mass of the Earth is below you, pulling you down. But once you are inside, part of the planet is now above you, pulling you back up. And there is a beautiful result hiding in that. For a sphere, all the mass in the shell above you cancels out perfectly. It tugs you in every direction at once, and the total effect is exactly nothing. Only the ball of rock still beneath you counts. So the deeper you go, the smaller that ball gets, and the gentler the pull becomes. Halfway down, gravity is roughly half of what it was at the surface, which sets up the strangest moment of the whole trip. At the exact center of the Earth, there is equal mass in every single direction. Gravity does not just get weak. It goes to zero. You are weightless, floating, at the center of the planet, and you are also moving faster than you have ever moved in your life. Now here is a subtlety worth being honest about. You would actually feel weightless for the entire fall, not just at the center. In free fall, there is nothing pushing on you, so there is no sensation of weight at any point. What is special about the center is that the pull itself has vanished, not just the feeling of it. Because gravity spent that entire descent speeding you up. By the time you reach the middle, you are traveling at roughly 7.9 kilometers per second. That is about 28,000 kilometers an hour. And nothing stops you. You go straight past the center. But now the whole situation flips. All that mass you just fell through is behind you, and it starts pulling you backwards. You are still going up, but you are slowing down. And here is the elegant part. You slow down at exactly the rate you sped up. So you arrive at the surface on the far side of the planet with a speed of precisely zero. For one perfect moment, your head pokes out of the ground on the other side of the world. If somebody happens to be standing there, they can simply reach out and take your hand. If nobody grabs you, gravity takes you straight back down, and you do the entire thing again. And again, forever. You have become a pendulum with a planet. So how long does one trip take? 42 minutes. About 42 minutes and 12 seconds. And that 42 minutes is not really about the size of the Earth at all. It depends only on how dense the planet is. A tunnel through a small ball of rock and a tunnel through an enormous one take exactly the same time, as long as the stuff they are made of is equally dense. And now the genuinely magical part. The tunnel does not have to go through the center. Dig a straight tunnel between any 2 points you like. London to Sydney, New York to Los Angeles. A short one across your own town. Step in with no engine and no push, just gravity, and every single one of those trips takes the same 42 minutes. A shorter tunnel is shallower, so gravity pulls you along it more gently, and you never build up as much speed. The two effects cancel out perfectly, which is why people sometimes call this idea a gravity train. There is one more coincidence buried in that number. 42 minutes is also about half the time it takes to orbit right at the surface of the Earth. Falling straight through the planet and skimming all the way around it take the same amount of time. Alright, reality. Every single part of this would kill you, spectacularly. The center of the Earth sits at around 5,000 degrees Celsius. That is roughly the surface temperature of the sun. You would not so much fall through the Earth as briefly become part of it. The pressure down there is about 3.5 million times the pressure at sea level. There is no material you could line that tunnel with that would stay a tunnel. And remember, we remove the air. Leave the air in, and it ruins everything. You would hit terminal velocity at around 200 kilometers an hour, and then just keep falling at that speed for hours. Worse than that, air gets denser as the pressure climbs. Long before you reach the center, the air beneath you would be thicker than you are. You would slow to a stop and simply float there, bobbing around in the middle of the planet. And the Earth is spinning. The tunnel would be sliding sideways underneath you the whole way down. So unless you dug it exactly pole to pole, you would be scraping along the wall for the entire journey. One quick myth while we are here. Almost nobody can actually dig to China. Tunnel straight down from most of the United States, and you surface in the Indian Ocean, somewhere west of Australia. The places that genuinely sit opposite each other are more like Spain and New Zealand, or Chile and China. So how close have we actually come? The deepest hole humans have ever drilled is the Kola super deep borehole in Russia, 12.2 kilometers. It took about 20 years, and it is roughly 1/5 of 1% of the way to the center. It got so hot down there that the rocks started behaving like plastic and kept squeezing the hole shut. We did not stop because we ran out of ambition. We stopped because the planet closed the door. So, 42 minutes, one moment of weightlessness at the heart of the world, and a hole that physics is never going to let you dig. If that rearranged your afternoon, subscribe to Curious Doodle, and maybe put the shovel down.